Hi guys, welcome to Excellent Scholars Academy, and in today's video we're going to look at Coulomb's law. Now, Coulomb's law talks about forces that exist between charges. And I'm going to start with explaining to you the first law. Now, Coulomb's first law states that Coulomb's first law states that unlike charges attract, while like charges repel. Okay, so it states that unlike charges will attract, but like charges will repel. Okay, for instance, if we have a negative charge and a negative charge, now if they try coming together, they're actually going to repel each other. Okay, so this will move in this direction, and then this charge will also move in this direction. So instead of them to move in the same direction, they're going to move in opposite direction, repelling each other. But if we have a positive charge here, and then we have a negative charge here, you would notice that they are going to attract each other. So this positive charge is going to move in this direction, and also this negative charge is also going to move in this direction. So they are going to move in the same direction because they are going to attract each other, because they are unlike charges. So you can see that from this diagram that like charges are going to repel each other, thereby moving in opposite direction. But unlike charges are going to attract each other, moving in the same direction. While these are going to move in opposite direction. Now, that is Coulomb's first law. Now we're going to look at Coulomb's second law. So Coulomb's second law states that the force of attraction or repulsion between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay, Coulomb's second law states that the force of attraction or repulsion, now that word is key. The Coulomb's force, which is also called the electric force, is not just a force of attraction or just a force of repulsion, but it's also a force of attraction and repulsion. So it says that the force of attraction or repulsion between 2-point charges is directly not directional, directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay, now mathematically it is given that the force of attraction or repulsion is directly proportional to the product of the charges q1, q2, and inversely proportional to the square of the distance between them. All right, so now we could bring this together to become F is directly proportional to q1, q2 over r squared. Now, for us to take away this proportionality sign and introduce a constant, this becomes F is equal to kq1 q2 over r squared. Okay, so this is Coulomb's force or electric force from the second Coulomb's law. Okay, so F is equal to kq1 q2 over r squared, where F, the force of attraction or repulsion, is measured in Newton. Now, K is the constant. Now, let me come here. K is the constant. K has a value of 1 over 4 pi E naught. Okay, this is the constant, and it has a value of 9 times 10 to the power of 9 Newton meter squared per Coulomb squared. Newton meter squared per Coulomb squared. Now, Q1 and Q2, Q1 and Q2 are measured in coulombs because charges are measured in coulombs. While R, the distance between them, is measured in meter. Okay, R, the distance, is measured in meter. R, the distance here, is measured in meter. So you might be wondering, what is this E naught? Now, E naught is actually the free space permittivity. The free space permittivity. And it has a value of its own of 8.854 times 10 to the power of minus 12 Newton per meter squared Coulomb squared. Okay, so E naught is the free space permittivity, and it has a value of itself as 8.854 times 10 to the power of minus 12 per Newton per meter squared Coulomb squared. Okay, I hope you understand all this that I did here, the first and the second law. So having this knowledge, you could understand Coulomb's law, and then you are going to be able to solve questions. So in the next video, I am going to be solving questions on Coulomb's law.